Hello students, welcome back. Let's take up another question. This question is from the chapter Magnetic Effect of Current. The question reads, what are magnetic field lines? How is the direction of magnetic field at a point determined? Draw the pattern of magnetic field lines of the magnetic field produced by a current carrying circular loop. Mark on it the direction of current and magnetic field lines. Name the two factors on which the magnitude of magnetic field due to a current carrying coil depends. Now, before going to discuss the magnetic field lines, let us know what is a magnetic field first. Now, this is the image of some iron filings or iron powder sprinkled on a surface with a magnet in the center. Here, this is the north pole of the magnet and this is the south pole of the magnet. As you can see here, these iron fillings have rearranged themselves in a definite pattern around this magnet. This pattern represents the magnetic field around the magnet. We cannot see the magnetic force acting on these iron fillings, but we can definitely see here the effect of that force. It is due to this magnetic force existing around this magnet that the iron fillings have rearranged themselves. So this area or region around the magnet where the magnetic force exists or it can be experienced is called a magnetic field. And these lines depicting the direction and strength of the magnetic field are called the magnetic field lines. Now, if we represent these magnetic field lines in the form of a diagram, it will look somewhat like this. They are closed continuous curves. Outside the magnet, they run from north pole to the south pole, and inside the magnet, they go from south pole to the north pole. So I think now you have understood what is a magnetic field and what are magnetic field lines. Now let us write their definitions. So the region around a magnet where its magnetic force can be experienced is called a magnetic field, and the magnetic field lines are imaginary lines that represent the direction and strength of a magnetic field. So this answers our first question. Now let's go over to the next question. So the next question is, how is the direction of magnetic field at a point determined? Now, to determine the direction of magnetic field at a point, we place a magnetic compass at that point. Let me zoom it for you and show you. Now, to determine the magnetic field at a point, we place a small magnetic compass at that point, and the direction in which the north pole of the compass points represents the direction of the magnetic field. Now, this is a magnet. When we place a compass needle at this point, you see the north pole is pointing in this way. So, we plot a point here. Next, we place the magnetic needle or compass at that point and see that now the magnetic compass north pole is pointing in this way. So we put another point here. Now again we place the magnetic compass or the needle at this place and see in which direction the north pole is pointing. We see that it points in this way. So we put another point here. So in this way, if we go on plotting points, we will arrive at a pattern like this. So when we remove the magnetic needle or the compass, we will get a line like this. This is a line which represents the magnetic field, and this line is known as the magnetic field line, and it goes from the north pole to the south pole. So now I hope you have understood how to draw the magnetic field lines. So this is the way in which you can easily draw the magnetic field lines. A similar pattern will be observed on the other side also, running from north to south. Similarly, you can draw several lines representing the magnetic field lines on either side of the magnet. This answer can be written as, the direction of magnetic field at a point can be found by placing a small magnetic compass at that point. The north pole of the needle of the compass indicates the direction of magnetic field at a point where it is placed. So this answers your second question. The next question is, we have to draw the pattern of magnetic field lines of a magnetic field produced by a current carrying circular loop, and on that we have to mark the direction of current and magnetic field, and we have to state two factors on which the magnitude of magnetic field due to current carrying coil depends. So let's write down. So this is the actual image of the pattern of magnetic field lines created due to current passing through a circular loop. Now, as you can see here, there are concentric circles which are formed around the center of the loop on both the sides. So here, a current carrying circular loop creates a magnetic field both inside and outside the loop. The magnetic field lines forms concentric circle. As you can see, the magnetic field lines forms concentric circles around the loop, and the field is strongest at the center of the loop and weakens as we go farther and farther away. The direction of this magnetic field can be determined using the right hand thumb rule. It says if you hold a current carrying wire with your right hand such that your thumb points in the direction of current, then the direction in which your fingers will curl will represent the direction of magnetic field. So as you can see on the left hand part, the current direction is upward. So here we see that if the current direction is upward, the fingers are pointing anti-clockwise. So this will be the direction of magnetic field around this side of the circular loop, and the current goes in this way. Now on the other side, the direction of current is downwards. So now if the current direction is downward, we see that the fingers are curling in this way. So now the magnetic field lines will be in the clockwise direction, as you can see in the image. Now as we go farther and farther away from the center of this loop, this circle becomes bigger and bigger, and at the middle of the loop, these lines are almost parallel to each other, as you can see over here. So the magnetic field lines at the center of the circular loop are in the form of concentric circles, but as we move away further and further from the center, we see that the magnetic field lines are almost parallel to each other. Now this is the diagrammatic representation of this. So here a wire carries current, and here the current goes in the upward direction, and on this side it goes in the downward direction. The magnetic field lines are in the form of concentric circles on the left hand side loop. If we apply right hand thumb rule, we see the magnetic field lines are anti-clockwise, and if on the other side, if we apply the right hand thumb rule, we see that the magnetic field lines are in the clockwise direction, and at the center they are almost parallel to each other. So this is the diagram for the pattern of the magnetic field lines in a circular loop. Next, we have to draw the direction of current and the magnetic field. Here we have shown the direction of current and the direction of magnetic field around this circular loop. Now, if you are finding this difficult to draw, let me explain you an easier way to draw this. So, this is a sheet of paper in which we have made two holes, and here we take a wire. From the bottom of that sheet, we just make a circular loop out of this wire, insert it, and on the other side, this wire is connected to a source of potential, and this is the key, and here is your circular loop. So I have represented here a single loop of wire. This is the direction of current. Here it is downward, it is upward, and here are the magnetic field lines in the form of concentric circles around this wire. On this left side, the magnetic field lines will be anti-clockwise, and on the other side, the magnetic field lines will be clockwise, and in the middle they will look somewhat like this. So this is the representation of the magnetic field due to a current carrying circular loop, representing the direction of magnetic field and current. So here you can write magnetic field. Alright, so this is the diagram. You can easily draw a nice diagram representing the magnetic field due to a current carrying circular loop in this way. So I hope you have understood this. Now let us see the factors on which the strength of the magnetic field due to current flowing in a circular loop depends on. The factors that determine the magnitude of the magnetic field produced by a current carrying coil are the amount of current flowing through the coil and the number of turns in the coil. So if you increase the amount of current in the coil, the field strength will increase. And if you increase the number of turns of the coil also, the magnetic field strength will increase accordingly. So these are the factors that determine the strength of the magnetic field. So I hope you have understood the solution to these questions. That's all in this video. If you found this video helpful, please do like this video, share it and subscribe to the channel. Thanks for watching. Please watch the playlist containing the solved physics questions and numericals from the previous year's board exams. I've shared the link of the playlist in the description box. It will be very helpful to you while preparing for your exams.